It is time to introduce the project I will be working on in parallel with continued Volatus LabVIEW development. So this is the kicking off point for a C++ version of the Volatus data acquisition and control software stack. So just in case you aren't familiar with a lot of the other videos I've been posting on my channel recently, Volatus is a data acquisition and control software stack designed for uh, both being useful for small data acquisition systems for component tests, small facility control setups, but as well as being able to scale up to large distributed systems like you might get at a rocket engine test stand with multiple operators on consoles, data acquisition equipment scattered across GSE and the test cell with varying levels of low level rocket engine control or integration with external engine controllers. It's been pretty successful, but it is starting to hit its limits already in the LabVIEW environment. So even when I started the Volatus LabVIEW development, I had expected to at some point migrate away from LabVIEW. Even at my previous employer, we had run into lots of issues with large LabVIEW project code bases, build times scaling to up to 8 hours or more in some cases for applications. And then there's just a minefield of app builder bugs that, despite me spending some time root causing and digging into a bit and giving NI some information, they just have not engaged with me on it. There are workarounds, but you have to remember to apply the workarounds, and that's something I frequently forget and get through a series of builds on a number of applications. Mine don't take 8 hours, but they're still long enough that I get through the build, try to do my first validation run with the new software, and realize that I forgot to make sure a dependency got built into the executable properly because App Builder is apparently incapable of doing that correctly. Yeah, there's other factors. So I've got the sticky notes here on the right. There's other factors. I do have for LabVIEW a very good GUI framework. It has enabled the end users of the software I've written over the past year to create and modify GUIs without ever having to open a block diagram. And just recently, I started rolling out the GUI editor tooling to them to streamline that even further. But you still can't do dynamic GUI stuff at runtime. I can't create new elements and add them to front panels. I know some ways I could accomplish that, but the level of burden for developing mechanisms like that and the inefficiency of how it would have to run in the runtime engine in LabVIEW just make it impractical. If I migrate to C++, I can just create new GUI elements. There's going to be a bunch of stuff that's just rendered as sprites as if it was, a game engine. Basically, a data acquisition control application is a video game for all of the underlying tech that's involved. And that's partially the direction I'm planning on going in with this migration. And of course, there's performance issues with LabVIEW and its built-in memory management that we don't have direct control over. I am at the limits of some of the capabilities we're trying to do on the Compact Rio platform. And we're using the CRIO 9047 primarily, so it's not a small CRIO, but compared to the efficiencies I could get with more purposeful memory management myself in C++, I expect I could get to about a quarter of the runtime resource requirements in a C++ based application. Things like distributing the data to multiple places for logging and publishing over the network, and things that will inherently get LabVIEW to automatically make memory copies because it doesn't know what I'm doing with that data. But I know that with that data, I don't need to modify it. I don't need a separate copy to get that buffered into a log, and then a separate copy from that to send to the module that's going to publish on the network. Both of those could use that data in parallel, and I have to do more of the work myself to manage that, but that would eliminate most of the memory copies that happen in LabVIEW. One of the goals I have is to get to basically beyond startup initialization. For most of the data acquisition applications, there shouldn't need to be any new memory allocations once the configuration is applied and we've gone through a warm-up cycle or two in the different code modules. And then NI licensing has been an absolute pain. Their move to distributor partners just is not a valid approach from what I can see. It can take weeks to get just 2 new seats added to volume license, and your email chains will grow to lots of people, 99% of which do not, well, maybe, okay, 90% of the people in the email chain are completely unfamiliar with the NI software stack and how volume licenses work, and will tell you that they've done the thing that you need to do, but you still need 2 or 3 more emails exchanged to actually get a license file once you do finally get everything through and they tell you it's ready. And then why now? Well, I've spent the last month ramping up on modern C++. I did go to school for computer science, and when I was in courses that were using C++ at university, the C++ 11 standard didn't even exist yet. Well, it was in draft, but I don't even know that C++ 98 had made it into curriculum yet. So standards-based C++ just did not exist when I was in school. But I've spent the last couple of weeks getting ramped up on that. I remember the first time I looked at a modern C++ code base, I didn't recognize, like, I could understand the high-level organization of it, of course, with the classes and module layout and the build system configuration. I could understand the high-level organization of things and the module architecture, but things like lambdas and the new way to do type aliases and some of the newer move semantics and R values, and just there's been a lot of new features in C++ that I just did not keep up with because there was no need to. But I can now comfortably read modern C++ code bases. I'm sure I will have a whole bunch of struggles getting it all actually applied in practice for the first little bit, but this is the point where I am ready. This weekend, specifically, I have finally got a consistent template together. So here in GitHub, I have started a new organization for the Volatus software and starting this C++ development. At some point, I will probably pull the LabVIEW-based Volatus into this organization so that everything Volatus, because the idea is to keep the LabVIEW code base available. There are some other people that have expressed interest in it, and it's still a really good way for engineers and scientists and people to get involved with developing software for their testing and experiments they do. So I would like to continue to hone that and make that available as an option for doing some of the functionality in a Volatus test system or a Volatus deployment. But ultimately, the core is going to move to C++. Yeah, so I've got this template. I've identified the graphical frameworks I'm going to be using, so SFML and Texas GUI, and I've got a handle on more modern CMake best practices and CMake project organization. CMake presets didn't exist the last time I did a big ramp up on CMake. So yeah, lots of new learning over the last couple of weeks. Yeah, so this is the Volatus core for C++ repository. As you can see, it was generated from a template repository, which is why this part still says template. But I did want to quickly go through and demo what it's like to get a copy of this and start to do development with it. So I'm going to go ahead and clone this repository down. This does require having VS Code. It's probably going to open because that's the same. Yeah. No, I don't want you to start building. Go away. I'm going to have to clean up the build folder now. I don't want you yet. Stop being too automatic, VS Code. So VS Code is the IDE I will be using. This is all CMake based, so you could still do builds from command line, C line, any other software development environment that integrates nicely with CMake. I'm not planning on supporting Visual Studio directly, but at some point I might get a build configuration created for Visual Studio as well. So once you have VS Code, some things you're going to want to make sure you have is the C++ extension pack. This is directly from Microsoft. This will enable all the IntelliSense and configuration and getting all of your code completion things that you'll want. The other one is CMake. So the CMake tools, again, directly from Microsoft. You would need CMake installed and available in your system. So we can see that mine's available system-wide. I also have MinGW 15.2 installed via MSys2. So if you look up CMake, I just use the Windows installer that they have available. And for the GNU toolchain, I did that via MSys2. The one sticking point with the MSys2 documentation for installing a MinGW toolchain is you do also want to make sure you install the debugging tools. So look up VS Code's tutorials on getting MinGW installed and configured for VS Code. They have a bit more complete documentation on what you would need to install via MSys2 that isn't in MSys2's introduction. But once you have all of that installed, we can go ahead and open this project. Brain, where are we going? So there, Volatus software. Open with code. And most of the configuration and building is going to get done from the CMake tooling extension in VS Code. So we can see this is already doing the CMake configuration. I'm not sure if VS Code just always by default picks the first preset, but you could click this edit button. So this will be where all of the different supported build options are available. And that happens in this CMake presets JSON file. So this is a way for establishing configuration for different build environments. So they could be different tool chains, they could be different build settings like debug or release, and some other options. So for instance, when I go to build this for Compact Rio or for NI Linux Realtime for Compact Rio and PXI, we're not going to want the GUI components. We're going to want the networking component. We're going to want all of the Volatus components, of course, but we're not going to need SFM. We're not going to need the graphics part of SFML or TGUI. So there will be different options for that as I get to those points in the development. Yeah, so this is all still the template-based stuff. I haven't renamed any of this. One of the things in VS Code that can be helpful is when you're in this output tab at the bottom, this drop down towards the right is where you can go back to see your progress for CMake and build, because VS Code likes to automatically change what it's showing you quite frequently in my experience. But as long as your compiler is available, your toolchain, your CMake is installed and available, you should see this automatically kick off. And at the very end, it should say configuring done, generating done, build files have been written to a build folder. At that point, you're ready to build. So I can go back to the CMake tab, and I'm just going to do, on this build entry, click this little button on the right, which is just going to automatically build everything that is in that preset. Now, this is going to take a little bit because this is building SFML from source, which includes a lot of font handling, audio, networking. It's got its own string class to handle cross-platform Unicode better. So that's going to take a little bit to build. And then it will build TGUI, which is a widgets-based graphical GUI framework. So SFML is just for doing like low-level OpenGL-based primitive drawing, and it's got a bunch of functionality for doing basic shapes like ellipses, circles, rectangles, lines, text. It's got a bunch of stuff like that. That is the very base level capabilities of a graphics engine. And then TGUI gives the widget level, such as windows, or child windows, tab groups, tree views, buttons, checkboxes, sliders, all sorts of the things you'd be used to from like putting components on a front panel of a VI, or if you're in Visual Studio, your graphical window editor. And so that's the basis I'm going to do. I'll probably end up making a lot of my own widgets for TGUI, certainly for things like valves, pump control, things like that, to make it a little bit more familiar to what I've created for the LabVIEW software stack. But I'm certainly not going to have a requirement to maintain, pixel perfect graphics or anything like that. Additionally, there's stuff in like LabVIEW doesn't do partial transparency. This should be able to do partial transparency. So there'll just be a lot more capability I can take advantage of in this environment and stack than I have been able to in LabVIEW, despite how far I've gotten. But yeah, so included in this so far, and this applies for the this template that this is based on. There's the CMake list, which shows how to get SFML and TGUI integrated in. So there's some specific CMake scripts for getting that source code from Git and getting that integrated into this build project, as well as then defining the project, defining a version, and then starting to pull in the source code specific to this project. So in the source folder, there's another CMake list. This is where we're creating an example executable. It's got its source code that's just going to open a window and give a button and a circle, pretty similar to the SFML basic example that you've almost certainly seen if you've looked into SFML at all. And then just how it gets everything linked together. So pretty small, pretty minimal starting point, and just has some really basic code organization to make sure include directories are configured correctly. So this certainly doesn't need to be in a separate header file, but it is specifically so I can verify that I've configured the build correctly. And this is just going to give a real basic how do you handle events? How do you get a window created? And the indent is wrong on all of this. Oh, I need to fix that now. But getting a window going, getting the TGUI framework integrated with SFML, creating a shape, creating a button widget, doing silly things that you should never do with your widgets, like rotating them. But here's an example of a lambda, drawing a blank there for a second, and just a basic top-level loop for the program. So we can see now at the very bottom in the output, the build has completed, and it succeeded, as it did with code 0. So I can go either in the Explorer, go to Build, Source, and then I'm going to open this in the integrated terminal. And now in there we can see there's that example exe. So I can run that. I've got the window. I'm not sure how feasible it is to see, but when I mouse over this button, even though it's at a weird rotated angle, it gets a little bit darker black, and I can click it to close. I can also click the X in the corner to close. But this is kind of just the proof that everything is getting integrated, pulled in, linked, configured properly to produce a usable executable. So from this point, I'll be creating a couple of different applications and tools, and maybe make a standalone GUI editor, maybe only integrate it in the main application. We'll see where I get as I start developing this. But this is going to be the starting point for Volatus in its C++ incarnation. So curious if anybody else thinks it would be useful to have a C++ base for this. If anybody would be interested in helping be a guinea pig and testing it and verifying it. But this will be a project that I expect to be in use at my current job by this summer, by the end of this summer, and then just see where it goes from there. Another big reason for moving away from LabVIEW is being able to support other data acquisition platforms. So at my current job, there's been a big ramp up on Beckhoff DAC controllers because of the team that they hired built a rat that all had experience in industrial automation and using Beckhoff controls. And I should be able to get this to do builds that'll run on a Beckhoff controller. So just having that kind of single platform that can target not just different languages and build environments, but additionally different hardware platforms. So yeah, thanks for checking out this video. Feel free to let me know how crazy you think I am in the comments, or any other thoughts you have about this project. Catch you later.